Welcome back, grade 9 learners of St. Paul American School Clark, to today's explainer. We're diving into Unit 2, Lesson 1, covering angles, segments, circles, and geometric definitions. We're going to explore the foundational definitions that literally build the universe around us. And it all starts with just a single tiny dot. Okay, let's take a quick look at our agenda. We'll hit the explainer objective, explore those core geometric definitions, walk through a worked example on segments, do a quick misconception check, follow up with a formative check, and then wrap it all up with a summary. All right, Section 1, Explainer Objective, establishing the foundations of geometry. By the time we finish up here, you're going to have a rock-solid foundation in geometry without feeling overwhelmed. We're starting from scratch, literally 0 dimensions, and building all the way up to one-dimensional segments, rays, lines, and angles, and eventually those perfect 2-dimensional forms like circles. We're turning abstract concepts into actual tools you can use. Section 2, Exploring Geometric Definitions, building the universe from a single dot. So let's get building. But, before we even draw a single line, we've got to ask, where does the word geometry actually come from? While the historical hook here is actually super cool, the word itself breaks down into 2 roots. You've got geo, which, just like in geography or geology, means earth, and then metry, like in the metric system, meaning to measure. Put them together and it's earth measurement. When you're studying geometry, you are literally learning how to measure the earth. It's this massive, sweeping subject that dictates all the shapes and spaces around us. But to measure the Earth, we got to start incredibly small. The absolute simplest concept in the whole geometric universe is the point. It's simply a location. That's it. It has no length, no width, absolutely no height. It is strictly 0-dimensional. Think about it. If you're on a point, you can't move. You shift left, right, up or down, and boom, you're not on that specific point anymore. We usually label these unique little spots with a single capital letter, like point A. Okay, now that we've nailed down the 0D point, let's see what happens when we connect them. This bumps us up to one-dimensional shapes that we can actually move along. If we take point A and point B and draw a straight path between them, we get a line segment. It has 2 hard endpoints and a measurable length, like AB equals 5. Now what if we start at point A, pass right through another point, and just keep going forever? That's a ray. It has one starting vertex, but absolutely no end. And hey, if you connect 2 of those rays at that exact same starting vertex, you've just built an angle. Finally, if the path goes on forever in both directions, passing right through the points, that's a line. Since you can only move back and forth along these paths, they are all strictly one-dimensional. Now, let's jump into 2D space, where we can finally move up, down, left, and right. This brings us to the circle. I love this quote because it shows how the ancient mathematician Euclid defined a circle thousands of years ago in his book Elements. He called it a plane figure, meaning it's totally flat, contained by one line such that all the straight lines falling on it from a single central point are completely equal. So the big takeaway here is that a circle is built entirely around its unique center. And here's a fun fact from the sources. The word center actually comes from an ancient Greek word for a prod or a poker. It literally refers to that sharp, pointy leg of a drawing compass. From that center, if you draw a straight line right to the edge, you've got your radius. If you draw a line completely through the center, from edge to edge, that's the diameter. And that diameter perfectly cuts the circle into 2 equal semicircles. Moving right along to Section 3, Worked Example, Segments, Finding the Midpoint. Let's see how we apply this one-dimensional logic in practice. Picture a straight line. Step 1. We spot 3 points sitting right there on that exact same line, X, Y, and Z. Because they share the line, we call them collinear. Step 2. We measure things out and notice, hey, the distance from X to Z is exactly the same as the distance from Z to Y. So step 3, because those distances match perfectly and the points are collinear, we can confidently say that point Z is the midpoint of segment XY. It is sitting perfectly in the dead center. Section 4, Misconception Check, Clearing up common geometric mix-ups. Let's hit the brakes for a second and make sure we aren't falling into any common traps with these definitions. All right, here's a question for you. Think back to what we just talked about regarding dimensions. Can you actually move around on a point? The answer is a massive no. Remember,
a point is strictly zero-dimensional. It is nothing but a location. You can't move up, down, left, or right. In the abstract rules of geometry, if you move even a tiny fraction of a millimeter, boom, you are just not on that specific point anymore.
Let's try another one. This is a super classic mix-up when we start dealing with rays. When you're writing it down, is ray AD the exact same geometric figure as ray DA? No way, they are completely different. And this perfectly shows why order really matters for rays. Unlike a line segment, where segment AB and segment BA give you the exact same distance, a ray has a definitive starting vertex. Ray AD starts firmly at point A and shoots off infinitely through point D. Ray DA, well, that starts at point D and shoots off in the completely opposite direction through point A. So always check your starting vertex.
Section 5. Formative check. Test your foundation. Let's just do a really quick knowledge check to make sure these classical definitions are locked in. Okay, based on Euclid's classical definitions, what is the exact difference between a radius and a diameter? Think back to our 2D circle discussion and how those straight lines interact with the center point.
You guessed it, the radius originates right at the center point and terminates at the outer edge, the circumference. It's the measurement that determines the actual size of the circle. The diameter, though, is a straight line that passes entirely through the center, hitting the circumference on both sides. Because a diameter is basically just two radii sitting back to back, it perfectly bisects the circle into two equal semicircles.
Section 6. Summary and recap. The geometric universe defined.
All right, here's your ultimate cheat sheet for today. A point is a 0D location with zero movement. A segment is a 1D path with two clear endpoints and a measurable length. Rays and lines, those are 1D paths that stretch out infinitely in one or both directions, while an angle is formed right where two rays meet. A midpoint is that unique location dividing a segment perfectly in half, and a circle is a 2D plane figure defined by an edge that's totally equidistant from a single central point. Remember, geometry literally means measuring the Earth, and now you've got the exact vocabulary to start doing just that.
So now that you have this incredibly precise foundation of angles, segments, circles, and geometric definitions, the real question is, where are these basic shapes going to take you next? How will you use these seemingly simple 0D, 1D, and 2D building blocks to map out the complex three-dimensional universe we actually live in? It's something to think about as you continue your geometry journey. Thanks for joining this explainer, and keep exploring.